For Math 3 review number 2, I made a smaller version of the review to just hit some of the more fundamental concepts of each objective. So problem number 1 is simply describing the end behavior of a polynomial function. It all depends on the highest degree of x, so this is x cubed, so we know it's odd. And we also know the leading coefficient of that term is positive. So the rules for positive odd are low to high. So the graph should go from low to high. Now I followed it up with problem number 2, which is the exact same polynomial, only in factored form. So this is the factored form of this polynomial. We want to sketch it. We want to find the x-intercepts and the y-intercept. Well, since it's in factored form right here, the x-intercepts are going to be really easy. You set the factors equal to 0, so the x-intercepts are -1 and -5 and +2. We might as well go and mark those right now. -1, -5, and +2. Now they're all multiplicity 1, so they're all pass-throughs. And the y-intercept is actually easier to find in its unfactored form because it's the constant, -10. But even if you only had the factored form, you know you find the y-intercept by setting x equal to 0, so 0 plus 1 is 1, multiplied by 0 plus 5, which is 5, multiplied by 0 minus 2, which is -2. There's your -10 right there. 1 times 5 times -2 is -10. So your y-intercept is down here at -10. Now this was a 2, and this was a -5, and that was a -1. And we know the behavior of the graph is supposed to be low to high. And all of the zeros are pass-throughs, none of them are bounces. So let's take an attempt at graphing this thing. It would start low, come up, it would pass through, go around, come back down, pass through, and then go back up. And so it would do something like that. There's your low to high graph. Problem number 3, graph the function again, labeling the x-intercepts and the y-intercepts. Again, it's in factored form, which makes life really easy. -3x equals 0, so the x-intercept, the 0 for this factor would be 0. The 0 for this factor would be +4, and the 0 for that factor would be -3. Now, +4, that's a multiplicity 2. So it's going to bounce when we hit +4. And the y-intercept happens when x equals 0, so -3 times 0 would be 0. That's really all we need to know right there. But 0 minus 4 is -4. And then when you square that, you get 16. And then 0 plus 3 is 3. And so 0 times 16 times 3 is still 0. So not only is 0 an x-intercept, it's also the y-intercept. Now remember, we've got 4 right here, and it's a bounce. And we've got -3 right here, and it's a pass-through. So what would be the end behavior of this graph? My highest power of x would be x times x squared times another x. That would be x to the 4th. Okay. And it's negative, so negative and even means low to low. Start low and end low. So that's what that graph should do when we're done with it. And remember, 4 is the bounce. So we're going to start low, come up, come through, turn around, come through, make another turn someplace, and then bounce. And that's the behavior of that graph. The next two problems involve writing the specific equation that matches the polynomial. In problem number 4, we give the information in terms of the graph itself. Now, -2 is one of the zeros. So a factor had to have been x plus 2, but it was a bounce, so it had to have been squared. When we take that information with +1, the factor had to have been x minus 1, and this factor had to have been x minus 4, and again, it was a bounce, so it had to have been squared. So we begin with y equals a. That's going to be the last thing we find, is that leading coefficient. Multiplied by, this -2 tells us x plus 2 was a factor, and since it turned around instead of just passing through, that factor was squared. Multiplied by x minus 1, multiplied by x minus 4 squared. Again, because it bounced, it didn't just pass through. Now we're going to use the other piece of information that we know, the y-intercept. Okay. These zeros on the x-axis helped us develop the factors. The y-intercept is going to be the next piece of information we use. And critical to that point is the idea that y equals 30 when x equals 0. So you could actually think of that as an ordered pair, 0, 30. So we're going to substitute y for 30, and we're going to substitute 0 for x. So 0 plus 2 squared, 2 squared would be 4. 0 minus 1 would be -1, and 0 minus 4 would be -4, but then we square it, and it becomes +16. So 30 equals -64a. Solve for a, and you get a equals 30 over -64, which simply needs to be reduced to -15 over 32. So that's my a value. Now I can write the entire function that produces this graph. Y equals, put in the a value first, -15 30-seconds, and now just put everything else in factored form. X plus 2 squared multiplied by x minus 1 multiplied by x minus 4 squared. Problem number 5 is very similar to problem number 4, with the exception of the way that the information was given to you. Instead of showing you the graph where the zeros occur, it was given to you in information like this: f of -2 and f of 6 and f of -1 all equal 0. So that's telling you -2 is one of the zeros. And it's also telling you +6 is one of the zeros, and it's also telling you -1 is one of the zeros. Now, the other piece of information on this one isn't the y-intercept. It's a different point. F of 1 equals -90, so that means when x is 1, y is negative 90, so we're way down here somewhere. Okay. At 1, negative 90. So the rest of the problem is simply write the equation that'll make this graph work, and then let's sketch the graph. It told us it's a cubic, which means all three of these zeros must be single. We can't have any doubles, we can't have any bounces, so they're all pass-throughs. So let's start writing the equation. Y equals A times x plus 2. The only way that 0 can be negative 2 would be if this is the factor, x plus 2. And x plus 1 and x minus 6. Now let's use the other piece of information. When x is 1, y is negative 90. So I'm going to substitute negative 90 right here. Now instead of thinking of x's as being zeros, I'm going to think of the x's as being a 1. So 1 plus 2 would be 3, 1 plus 1 would be 2, and 1 minus 6 would be negative 5. So negative 90 equals 3 times 2 is 6, times negative 5 is negative 30, negative 30a, divide both sides by negative 30, and you get a equals positive 3. So the full equation, I'll put it in function notation, f of x equals 3 as the leading coefficient multiplied by the factors x plus 2, x plus 1, and x minus 6. That's the equation. Now let's just make sure we can graph this thing. The in behavior, it's a cubic function, and the leading coefficient is positive. So positive odd would go from low to high. Okay, let's take everything we know about this and graph this thing. We know it's a low to high end behavior. We know each one of these zeros is a single, so they're all pass-throughs. And I know I have to use the point 1, negative 90. So I'm going to start low. I'm going to come up, pass through, turn around, pass through again. I really don't know where I crossed the y-axis because we didn't find the y-intercept. But I do know I have to come down here, hit the point, turn around, go up, and pass through again. And there's a pretty good representation of the graph. On to the back side of review number 2. The back side covers factoring and division. I don't have any graphing back here because we hit graphing pretty hard on the front. So problems 6, 7, 8, 9 are factor completely. In problems 6 and 7, the factoring process has begun because you can see some parentheses. In problem number 6, we see that x plus 7 is a common factor for these two. So we're just going to pull that x plus 7 out as the common factor. What I'm really doing is I'm dividing both of these terms by x plus 7. And just like any other greatest common factor, when you find a common factor, you pull it out in front and you're left with whatever is left. And in this case, it would be 3x plus 5. And that would be the fully factored version of this problem. So 3x plus 5 and x plus 7. Are the factors. Now on problem number 7, if you look close, and I hope you do, these are not the same. In fact, they're exact opposites. 3 minus x is the exact opposite of x minus 3. So the way we're going to turn this 3 minus x into x minus 3 is we're going to multiply this back end of the problem by -1. And not only is it going to turn the 3 minus x into x minus 3, but it's also going to turn this plus 25 into minus 25. It's not going to do anything to the front part of this problem. So I'll just rewrite it. X squared times x minus 3. Now, I've got a common factor of x minus 3. So I'm going to pull it out as the common factor. And I'm left with x squared minus 25. And that x squared minus 25 is a difference of perfect squares, which can go down further to x plus 5, x minus 5. Don't forget the x minus 3. And there's your fully factored form of this problem. X minus 3 times x plus 5 times x minus 5. Problem number 8. Problem number 8 is a 4-term polynomial with nothing that's common to all 4 terms. So there's no GCF for all 4 terms. That's almost always just a dead giveaway that this is going to be a factor by grouping. Look for something common in the first 2, which I see a 3 and a y. So 3y is common to the first 2 terms. So if I factor the 3y out from the first 2 terms, I'd be left with just the x and then a plus 7. Now for the second 2 terms. Looks to me like what they have in common is a -2. So I'm going to factor out a -2, and what's left with is an x right there. And then notice the change of sign. -14 divided by -2 is positive 7. Okay. Now I have an x plus 7 that's common, so that's the common factor. And a 3y minus 2, that's the uncommon factor. So x plus 7 and 3y minus 2. Now, problem number 9 is just a trinomial term. The first term has 1 as its leading coefficient, so it's actually pretty easy. The only thing that's a little bit different is usually they begin with x squared, but this one begins with x to the 4th and has x squared as its middle term. So if you think the process of foiling, when you multiply, what are you going to have to do to get x to the 4th in front? But my middle term is going to be x squared. I'm going to have to put an x squared right here and an x squared right there. So that'll get me x to the 4th power as my first term. Now, moving on to the back. Factors of positive 20 that add up to -9. So that's -5 and -4. But the middle term isn't x, it's x squared. So we just need to make sure that this all works. X squared times x squared is x to the 4th. This would be -4x squared. This would be -5x squared. Combined like terms, there's your -9x squared. And then here's your positive 20. So if you FOIL it out, it really does work. Now the only thing here is this is a difference of perfect squares that can go down further. X plus 2 times x minus 2. Now x squared minus 5 really can't do anything. So there you go. X squared minus 5 is one of the factors. X plus 2 is one of the factors. And x minus 2 is one of the factors. Problems 10 and 11 are polynomial division problems. And the reason they're here in this unit is because factoring is really just another way of dividing. So problem number 10, divide using synthetic division. So we have this 5-term polynomial that starts to exit at x to the 4th power, works its way all the way down, and we're dividing by x plus 1. Now the problem did say use synthetic division, so let's use synthetic division. If x plus 1 is known to be one of the factors, so let's just use the 0 that would be created, which is -1. And let's use all the leading coefficients of the polynomial. It'd be 1x to the 4th, and it'd be -5x cubed. It'd be +2x squared. It'd be -8x, and it would be +6. So let's just start the process of synthetic division. And really that's what it is. It's a process. The first leading coefficient just simply comes straight down. And then the 0, which is -1, because of x plus 1, -1 times 1 is -1. Combined like terms, that would be -6. -1 times -6 is +6. Combined like terms, 6 plus 2 is 8. -1 times 8 is -8. Combined like terms, -16. -1 times -16 is +16. Combined like terms, 6 and 16 is 22. Now, since we did have a number left, that's the remainder. And therefore, my quotient is simply going to be knock the polynomial down by one factor, so it began with x to the 4th, but the answer is going to begin as 1x cubed minus 6x squared plus 8x minus 16, and then don't forget about the remainder, plus 22 over x plus 1. And I'm also having you practice on the very last problem, long division. So we have our trinomial x squared minus 3x minus 28, and we're trying to use x plus 5. So x squared divided by x. Take the first term of each. That x squared right there divided by that x. X squared divided by x is x. Now bring down your multiplication. X times x is x squared. X times positive 5 is plus 5x. All I did was I distributed as if x plus 5 had parentheses around it. Now change the signs. And then combine like terms. -3x plus -5x is -8x. And then bring down the minus 28. And do it all over again. Take the first term, which is -8x. Divide by the first term over here, which is x. And so that's -8. -8 times x is -8x. -8 times 5, -40. Change the signs. So that becomes a plus, and that becomes a plus. These cancel each other out like they're supposed to, and I'm left with a positive 12. -28 plus 40 is positive 12, so that's my remainder. I don't have anything else to come down. So the answer would be x minus 8 plus the remainder of 12 over x plus 5. So the final wrap-up question, is x plus 5 a factor of this trinomial, x squared minus 3x minus 28? And the answer is no. And the reason is we found a remainder when we divided. All right, so that's a much shorter review than the review that was in your packet, but it covered some of the more essential topics that were in this unit.